Oh hey, didn't see you there. You might be wondering why I'm here today. The reason is simple. I'm here to introduce you to the world's most epic math project. Before we continue, a quick message from today's sponsor,
Raid Shadow Legends.
You might be wondering, why is this math project so epic? We're only finding the center of mass of a lamina, right? Wrong, it's not just any lamina. We're gonna be finding the center of mass of these Yeezy Boost 350s. The thing is, we won't be finding the center of mass of actual Yeezys because I don't have actual Yeezys. So instead, I grabbed a series of equations in Desmos to make this flat, really scuffed looking Yeezy shape. To find the location of the center of mass of this Yeezy, we will be using these equations. The problem is, the region of this Yeezy is a bit awkward to integrate in one integral, so we will be splitting it into 5 regions. Since we're assuming constant area mass density of 1, we can just integrate the function 1 over each region and add them all together to find the mass. We can apply the same method to find the x and y component of the center of mass, integrating over each region separately and adding it all together in the end. Let's label the 5 sections as such and compile a table of all the integrals we need to do. If we start with region A, we can see that the x bound should go from 0 to 2, and the y bound should go from 8 to negative x minus 1 squared plus 18. We can just integrate 1 to find the mass component. For the x and y components of the center of mass, we just replace the 1 with x and y respectively. So that was region A, now we can move on to region B. I won't be narrating the rest of the sections because the process is the same. So just sit tight for a bit as I finish these integrals. Note that region C is the only region with a different order of integration, as that is the easiest way to find the area of C. Now that we've found all the components, we just need to do a bit of adding. Now all we need to do is refer back to this set of equations. To find the coordinates of the center of mass of the Yeezy, all we need to do is take the sum of the integrals in the x and y columns and divide those by the total mass. Now that we have our center of mass, let's give it a test. Here we have the sheet of cardboard that we'll be cutting our lamina from. We will be making a grid of 1 centimeter by 1 centimeter squares using this Yellowstone National Park ruler. Here's our grid. I only need an 8 by 18 grid because that's all the space that the Yeezy takes up.
A few moments later.
So I sketched the Yeezy as best as I could. Now let's cut it out. Not gonna lie, that's a pretty nice cut.
Nice!
So I marked the center of mass point that we calculated on this Yeezy, and now let's test it out. So I have a needle with some thread here. So if we stick it through this point and hold it up,
Nice.
it's balanced. Thanks for tuning in to the world's most epic math project. There isn't a single other math project in the world that has as much grip as this one.